So I think in the last class we started with refraction of light. So refraction of light we have discussed the definition. So refraction is nothing but what? The bending of light when it is traveling from one medium to other medium is called as what? Refraction of light. Okay. So here in which direction the light will bend? So ಯಾವ directional light bend ಆಗುತ್ತೆ ಅಂತ ನಾವು based on the medium we can say whether it is bending towards the normal or whether it is bending away from the normal, that we can identify. Yes. So here we have the denser medium, rarer medium, idu kuda discuss madidvi. Laws of refraction discuss madidvi. Then the glass slab experiment also we have discussed, but I'll start from this point. So idana just revise ಮಾಡಿ continue ಮಾಡೋಣ. So see here, this whatever PQRS blue color you are observing, this is a glass. Okay, so it is a glass slab anta ಹೇಳ್ತಾರೆ. So for this glass slab PO, or you can see this whatever the red line you are observing. So this red line first. So first till ನಾವು ಏನು ನೋಡ್ತಾ ಇದೀವಿ, that is our. Okay, so here what you are observing, this is this part. So this part, it is nothing but the incident ray. So this is the incident ray. So here what you are observing. Then next here what is happening, the next one. So from this glass slab you are observing this one more line. So here you are observing this one more line. Yes. Then next again this is going out of the glass slab. So here first is the incident ray. Second time when it is passing through the glass slab, it is called as the refracted ray. And then next when it is going out of the glass slab, it is called as the emergent ray. So first we have incident ray, refracted ray, and the emergent ray. So we have the normal drawn to the surface. Aita? So what is this experiment? So experiment idenanta irutte, that is we will consider a glass slab on a paper. So on the paper naven ಮಾಡ್ತೀವಿ, one glass slab ಇಡ್ತೀವಿ. On the one side, so one ಕಡೆ ಏನು ಮಾಡ್ತೀವಿ, ಎರಡು object ಅನ್ನ place ಮಾಡ್ತೀವಿ. So that object I told you last class, that is we may consider the object. Here what we will consider, that is the object. Yes. So here separately I'll show you one second this. Yes. Here you can see side, I'll show that. So this on the paper we will consider a glass slab. So for this glass slab, here somewhere I'll keep two objects. Okay, so two objects which are almost like it is parallel to each other, you can see. So ಏನ್ object ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ, it is like a paper pin ಏನಿರುತ್ತೆ. So paper pins ಅನ್ನ ನಾವು ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. So one I am placing here, one I am placing here. Okay, then next, so what I'll do after placing this glass slab from the other side. So ಈ ಕಡೆ ಆಯ್ತು, ಈ ಕಡೆ ಬಂದು ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, I'll observe these two pins. Okay, so first table ಮೇಲೆ ಪೇಪರ್ ಇಟ್ಟು, ಪೇಪರ್ ಮೇಲೆ ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್ ಇರುತ್ತೆ. ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್ one side ಎರಡು ಆಬ್ಜೆಕ್ಟ್ ಪ್ಲೇಸ್ ಮಾಡ್ತೀವಿ. ಮತ್ತೊಂದ್ ಕಡೆ, ಮತ್ತೊಂದು ಅದರ್ ಸೈಡ್ ಆಫ್ ದ ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್ we will observe that one. ಸೊ ನೀವು ಇದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ ಇದು ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್ ಇರೋದ್ರಿಂದ ವಾಟ್ ಎವರ್ ದೀಸ್ ಟು ಆಬ್ಜೆಕ್ಟ್ಸ್ ಯು ಆರ್ ಕೆಪ್ಟ್ ಹಿಯರ್, ಇದ್ರದ್ದು ಇಮೇಜ್ ನಮ್ಗೆ ಈ ಕಡೆ ಕಾಣಿಸುತ್ತೆ. ಇದ್ರದ್ದು ಇಮೇಜ್ ಏನಾಗುತ್ತೆ, ಈ ಕಡೆ ಕಾಣಿಸುತ್ತೆ. ಆಯ್ತಾ? ಸೊ ನಾವು ವಿ ವಿಲ್ ಜಾಯಿನ್ ದೀಸ್ ಟು ಪಿನ್ಸ್. ಸೊ ಫಸ್ಟ್ ನಾವು ಇದೆರಡು ಲೈನ್ ಅನ್ನ ಜಾಯಿನ್ ಮಾಡ್ತೀವಿ, ನೆಕ್ಸ್ಟ್ ಇದೆರಡು ಲೈನ್ ಅನ್ನ ಜಾಯಿನ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ದ ಗ್ಲಾಸ್ ಸ್ಲ್ಯಾಬ್ hope so you are able to see the PPT. So when you are observing this phenomena, you can see that a ray of light, when it is traveling from air to glass, it is bending towards the normal. It is bending towards the normal. Same way, glass in the when it is traveling from glass to air, it is bending away from the normal. So according to the refraction phenomena and the laws, so this figure is clearly observed. So here the angle of incidence note bodu, then angle of refraction, angle of emergence. Okay. So this is your glass slab experiment. Here this is the numerical, later we can see. Yes. So what is lateral displacement? It is the perpendicular distance between the emergent ray and the incident ray produced forward is called as what? Lateral displacement. So you will note that if you observe this refraction through a glass slab, here whatever the emergent ray is there. So this emergent ray and this incident ray. So if I extend this incident ray, you will note both the incident ray is somewhere going along this direction. So in refraction phenomena, if the incident ray, if it is traveling in the straight line, this path that follow the incident ray would have followed this path. Now this is emergent ray. This is your extended incident ray. The perpendicular distance. So either the lane perpendicular distance is there. This is called as what? Lateral displacement. This is called as lateral displacement. I hope the lateral displacement is clear to you. Then the next point in this lesson, I think we are going to start with the lenses. So till now we discussed about the mirrors. So mirror ಬಗ್ಗೆ discuss ಮಾಡಿದ್ವಿ. Now we will see what you mean by a lens. What are the different types of the lens? So here we have a lens. If you consider the mirror, only one surface will be reflecting. So mirror only one surface will be reflecting and the other surface will be opaque. But if you consider the lenses, both the surfaces will be a refracting surface. Yes, both the surfaces will be refracting surface. If two surfaces, two different refracting surfaces, when it is combined, it will give you a lens. So iden kodutte nimge lens kodutte when two refracting surfaces are combined together. So namatra basically for our study we have two lenses. Actually we can see many examples for lenses, but here we have the two lenses. That is the concave lens and the convex lens. So what is concave lens? What is convex lens? So convex lens ಅಂದಾಗ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ here this is your convex lens. So convex lens ಅಲ್ಲಿ the center will be bulged one. The center will be bulged one and at the edges it will be thin. So at the edges it will be thin. This is called as what? Convex lens. So at the center it will be bulged and at the edges it will be thin. This is called as the convex lens. Concave lens ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ concave lens is what? It is thin at the center. It is thin at the center and it is bulged at the edges. It is bulged at the edges. So this is called as what? Concave lens. I hope the convex lens and the concave lens is clear to you. So here we have the figure also. You can see this. Yes. So concave lens and the convex lens. Again we have plano concave lens, plano convex lens. So again we have different types of lenses also here. Similar to the mirror, lenses al kuda kelon terms barutte, like we have the center of curvature. If you see for the mirror, there also we have the center of curvature. Pole irutte. So mirror alli yavade terms study ಮಾಡ್ತೀವಿ. In the mirror, the center part is called as the pole. Next, so iden reflecting surface irutte, idakke aperture anta ಹೇಳ್ತಾರೆ. It is called as the aperture. Then we have the center of curvature, the distance between center of curvature and pole, it is radius of curvature. We have the focus and the distance between focus and the pole, it is called as the focal length. So these are some of the terms related to your mirror here. ಇದೇ ತರ ಲೆನ್ಸ್ ಅಲ್ಲಿ ಕೂಡ ಬರುತ್ತೆ. ಇಲ್ಲಿ ನಾವು ಪೋಲ್ ಅಂತ ಹೇಳಲ್ಲ, ಲೆನ್ಸ್ ಅಲ್ಲಿ ದ ಸೆಂಟರ್ ಪಾರ್ಟ್ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ optic center anta ಹೇಳ್ತಾರೆ. This is called as what? Optic center. So we don't call it as pole, we call it as the optic center. Okay. So similarly, in case of a lens, here ಇಲ್ಲಿ ನೋಡಿ, this is one curved surface ಹೌದಾ. So ಇದೊಂದು curved surface ಇದೆ. ನಾನು ಇದನ್ನ with respect to this I can extend. I'll get one circle. I can extend this also. So this is my one more circle. So whatever these two circles are there, with respect to this, we have the center of curvature. With respect to this also, we have the center of curvature. Similarly, we'll get radius of curvature value ಕೂಡ 2 ಬರುತ್ತೆ ಹೌದಾ. So one curved surface ಗೆ one value ಇರುತ್ತೆ, ಮತ್ತೊಂದು curved surface ಗೆ one value ಇರುತ್ತೆ. Suppose ನೀವು ಎರಡು ಏನ್ ಇಲ್ಲಿ curved surface ಇದೆ, that is this one and this one. If ಎರಡು radius of curvature equal ಇದ್ರೆ, okay. So if for the radius of curvature of the first lens and the second lens, second curved surface and the first curved surface, if it is equal, then it is called as what? Equiconvex lens anta ಹೇಳ್ತಾರೆ. It is called as equiconvex lens. Yes. So convex lens we have many different types. ಎರಡು radius of curvature equal idre, it is called as equiconvex lens. I hope the equiconvex lens is clear to you. Okay. So center of curvature, principal axis is nothing but the line passing through the center of curvature, and the optic center is called as the principal axis. So principal focus, where the rays appears to converge or diverge from the on the principal axis, that point is called as what? Principal focus. So focal length, the distance between the focus and the optic center. Yes. So all the definitions same like your. It is same like your lens mirror. Okay. Mirror alli yav tara terms ana study ಮಾಡ್ತೀರಾ, for lenses also the terms are same. Okay. Now we have, so if you want any point repeat, you can tell. So today our target is to complete this lesson. So uses of concave lenses. So concave lenses uses new notebodu. Concave lenses used in glasses. Concave lenses are used in the lasers. These are used in the cameras. These are used in the flashlights. These are used in the peepholes. So these are the different uses of the concave lenses. Similarly, convex lens ಅನ್ನ ಎಲ್ಲೆಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂತಂದ್ರೆ, the convex lens is used in the microscopes and magnifying glasses to subject all the light to a specific point. This convex lens is used in the camera lens in cameras as they focus light for a clean picture. So convex lens, concave lenses, both are used in the cameras based on the uses what you require. Next, it is used in the telescope also. Then convex lens is used in the correction of hypermetropia. So what is hypermetropia and all that we can study in the next lesson. So just remember the uses of both concave lens and the convex lens. Here we have the lens formula. Already now mirror formula study madidvi. What is that mirror formula? The mirror formula is given by 1 by f is equal to 1 by u plus 1 by v. This is mirror formula. Similarly, mirror magnification anta study ಮಾಡ್ತೀವಿ. That magnification is given by minus v divided by u. Same way for the lenses. So lens alli lens formula ಏನಂತ ಬರುತ್ತೆ? 1 by v minus 1 by u is equal to, it is 1 by f. 1 by v minus 1 by u is equal to 1 by f. Then here the magnification is given by v divided by u. So ಇಲ್ಲಿ ನೀವು ಕಂಪೇರ್ ಮಾಡಿ ನೋಡಬಹುದು for mirror and the lenses. So mirror formula plus ಬರುತ್ತೆ, lens formula ದಲ್ಲಿ minus ಬರುತ್ತೆ, magnification ಇಲ್ಲಿ minus ಬರುತ್ತೆ, magnification ಇಲ್ಲಿ plus ಬರುತ್ತೆ. Okay. The common formula is magnification is the height of the image to the height of the object. It is same for both lens and the mirror. Then the point is, that is power of a lens. So what is power of a lens here? Power of lens is nothing but what? The reciprocal of the focal length. The reciprocal of the focal length is called as what? Power of the lens. The reciprocal of focal length is called as power of a lens. Okay. So this power of a lens is expressed in terms of diopter. It is expressed in terms of diopter, denoted by capital D. Yes, any doubt is there? Shreya, Rehan. Then lastly, we have the image formation. Artha idea, or if you want me to repeat any point, you can tell. We will see the last point, that is the image formation by convex and the concave lenses. Shall I continue? Next point.
Yes, ma'am.
Okay. So 1 minute, I'll share that. Here you can see the ray diagram, image formation by a convex lens. So in case of a concave mirror, concave mirror alli 6 case barutte. Here in case of convex lens, we have the 6 cases. So here you can see the position of the object. That is first case, when the position of the object is at infinity. So new ray diagram nodi helbodu, where the image is getting formed here. The image is formed at focus. So here you can see F1, F2 point also you can observe. So in the figure, so here you can see when the object is at infinity, the object image is formed at F2. The position of the image is at F2 and the image is real and inverted and it is highly diminished. Correct. So ನೀವು ಈಗ ಕಂಪೇರ್ ಮಾಡಿ ಕೂಡ ಸ್ಟಡಿ ಮಾಡಬಹುದು. ಇನ್ ಕೇಸ್ ಆಫ್ ಕಾನ್ಕೇವ್ ಮಿರರ್, ಅಲ್ಲಿ ಫಸ್ಟ್ ಕೇಸ್ ಅಲ್ಲಿ ಏನಂತ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ, when the object is at infinity the image is formed at the focus. So instead of that ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತೀವಿ, the image is formed at F2. Okay. Next, second one, that is the image is behind, so the object is behind 2f1. Actually ಇಲ್ಲಿ ನಾನು ನಿಮಗೆ ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೆ, for the lenses we will get f1, f2, c1, c2, like that we will get here. So 2f1 is nothing but what? It is actually the center of curvature. Okay, so 2f1 ಅಂತಂದ್ರೆ center of curvature ಬರುತ್ತೆ. So the object is beyond 2f1, then the image is formed between f2 and 2f2. So object ellide behind the point f2, f1, and the image is formed between f2 and 2f2. Yes. So here you can see this one, f1 to f1, f2 to f2. So it is AB is the object. Here you can see between f2 and 2f2 the image is formed and the image is inverted and it is a real and diminished. Object size ಗಿಂತ ಕಡಿಮೆ ಇದ್ರೆ diminished size. Okay na. Third case. So in the third case, when the object is at 2f1 andre at center of curvature, the image is formed at 2f2. So very simple case to understand and to remember. When the object is at 2f1, the image is at 2f2. So what is the image here? It is real and inverted and it is of the same size. So object same size is there, the image is also of the same size. Fourth case, the object is between f1 and 2f1. Andre ಫೋಕಸ್ ಮತ್ತೆ ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್ ಮಧ್ಯದಲ್ಲಿ ಅಥವಾ F1 and 2F1 where the image is formed. The image is formed behind. The image is formed not behind, that is after the 2F2 point. It is formed beyond the 2F2 point. This is also real and inverted and it is enlarged one. So first two cases diminished, third case same size, fourth case enlarged one. Then next, so next figure you can see here, that is the fifth case. When the object is at F1, when the object is at F1, the image is formed at infinity. The image is formed at infinity. First case is reverse ಇದೆ ಇದು, and it is also real and inverted. It is also highly enlarged. Then the sixth point, it is between F1 and object, F1 and the center of curvature or the optic center. The image is formed on the same side and it is virtual and the erect and it is highly enlarged. It is highly enlarged. So these are the 6 cases regarding the convex lenses. So ನೀವು ಇಲ್ಲಿ ಯಾವುದೇ ಕೇಸ್ ತಗೊಂಡು ಸ್ಟಡಿ ಮಾಡಿದ್ರೆ you can see based on the ray diagram. So ನೀವು ray diagram ಅಲ್ಲಿ ಯಾವ ತರ ಸ್ಟಡಿ ಮಾಡ್ತೀರಾ? When the ray is parallel to the principal axis, it is passing through the focus after refraction. When the ray is passing through the focus after refraction going parallel to the principal axis, ಎಲ್ಲಾ ಫಿಗರ್ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ the laws, 4 laws ಏನ್ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ ನಾವು ಅದು ಇಲ್ಲಿ ಒಬೇ ಆಗ್ತಾ ಇದೆ. So these are the 6 cases regarding the convex lens. So for the concave lens only 2 cases are there. That is when the object is at infinity, the image is formed at F1. When the object is at infinity, the image is formed at F1 and the nature is virtual and the erect and the size is highly diminished. Okay, so this is for what? This is for the concave lens. When the object is at infinity, the image is at F1. Second case, between infinity and the optic center. So first case infinity anta study ಮಾಡ್ತೀವಿ. Second case anywhere on the principal axis. So anywhere on the principal axis where the image is formed, it is between F1 and optic center. Nature is virtual and erect and here it is size is diminished. So ನೀವು ಇಲ್ಲಿ ನೋಡಿದಾಗ ಏನ್ ಇದ್ರದ್ದು ಕನ್ಕ್ಲೂಷನ್ ರೆಡಿ ಮಾಡ್ಬೇಕಂತ ಅಂದ್ರೆ, in case of mirror ಅಲ್ಲಿ ಏನಂತ ಹೇಳಿದ್ವಿ ನಾವು, concave mirror all the 5 cases. So I'll tell you what is the summary or the conclusion here. Concave mirror all the 5 cases, the image is real and inverted. The image is real and inverted. Only for the 6th case. 6th case ಅಂದ್ರೆ pole ಮತ್ತೆ focus ಮಧ್ಯೆ ಇದ್ದಾಗ the image is virtual ಅಂತ ಹೇಳ್ತಾರೆ. The virtual and erect image. Then in case of convex lens, this is for the concave mirror. Next, convex lens ಅಲ್ಲಿ ಇದೆ repeat ಆಗುತ್ತೆ. For the first 5 case, the image is real and inverted, and for the 6th case, it is virtual and erect. Next, convex mirror. So convex mirror ಅಲ್ಲಿ there you will get virtual and erect. Similarly, in case of convex lens also it is same, virtual and erect. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? So compare and study. So compare ಮಾಡಿ study ಮಾಡಿದಾಗ easy to remember. Otherwise in the exam you will get confused. Okay. So remember these all summary or regarding the image formation. So ಯಾವ್ದಾದ್ರು one question ಅಂತೂ ಬಂದೇ ಬರುತ್ತೆ. Draw the ray diagram when the object is at infinity, when the object is at focus. So lens ಕೇಳಿದಾರ, mirror ಕೇಳಿದಾರ ಅಂತ confirm ಮಾಡಿ, then you can proceed with the question. Okay. So I think this completes your entire light chapter. So any doubt is there? Shreya and Rehan, otherwise we can go for some question answers. Okay, you sit with the book and the pen. So book ಮತ್ತೆ pen ತಗೊಳ್ಳಿ. We will solve some questions. Next one more class. ಮತ್ತೊಂದು class ಅಲ್ಲಿ next Monday class ಅಲ್ಲಿ ನಾವು exercise ಅನ್ನು complete ಮಾಡೋಣ. We can go for the next human eye lesson after this. Any doubt, any concept you want me to repeat? So the lesson summary, first we have started with what is light, properties of light, what is reflection of light, terms related to the reflection of light, laws of reflection. Next to convex and the concave mirrors we have studied, the image formation, how the image formation takes place, what is the uses of concave and the convex mirror, mirror formula, magnification, ಆಮೇಲೆ ರಿಫ್ರಾಕ್ಷನ್ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ರಿಫ್ರಾಕ್ಷನ್ ಥ್ರೂ ಎ ಗ್ಲಾಸ್ ಸ್ಲಾಬ್, ಫಸ್ಟ್ ಲಾ, ಸೆಕೆಂಡ್ ಲಾ, ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್, ದೆನ್ ಲೆನ್ಸಸ್ ಅಲ್ಲಿ ಕಾನ್ವೆಕ್ಸ್ ಅಂಡ್ ದ ಕಾನ್ಕೇವ್ ಲೆನ್ಸಸ್, ಇಮೇಜ್ ಫಾರ್ಮೇಶನ್, ಲೆನ್ಸ್ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ, ಮತ್ತೊಂದು ಲೆನ್ಸ್ ಮೇಕರ್ಸ್ ಫಾರ್ಮುಲಾ ಅಂತ ಬರುತ್ತೆ ಆಯ್ತಾ. ಸೊ ಲೆನ್ಸ್ ಮೇಕರ್ಸ್ ಫಾರ್ಮುಲಾ ಯು ಡೋಂಟ್ ಹ್ಯಾವ್, ಯು ಹ್ಯಾವ್ ಓನ್ಲಿ ಲೆನ್ಸ್ ಫಾರ್ಮುಲಾ. ಸೊ ಲೆನ್ಸ್ ಫಾರ್ಮುಲಾ, ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್, ಪವರ್ ಆಫ್ ಎ ಲೆನ್ಸ್. Okay. So I hope you have this book and the paper. We will go for the numericals now. Okay. So here I'll display the first question. You can solve that. Yes. I hope you are able to see the question. That is, a concave mirror of focal length 20 centimeter is placed 50 centimeter from a wall. So you have a mirror of focal length 20 centimeter, then it is placed from a wall 50 centimeter away. Focal length 20 centimeter antide. Then next you have the how far from the wall an object be placed to form its real image on the wall. Object distance kelidare, image distance already kottidare, it is 50 centimeter. For a concave mirror we need to calculate the object distance u value. So we know mirror formula. So according to mirror formula we can simplify this. So question note down ಮಾಡ್ಕೊಳ್ಳಿ and try to solve it. So for the concave mirror, the focal length is 20 centimeter. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ concave mirror ಗೆ the focal length is taken as negative. ನಿಮ್ಗೆ ಯಾವ್ದಕ್ಕೆ ಪಾಸಿಟಿವ್ ತಗೋಬೇಕು ನೆಗೆಟಿವ್ ತಗೋಬೇಕಂತ ಗೊತ್ತಿದ್ಯಾ, or I should give some short note for that? Yes, students. ಸ್ನೇಹಾನ್, ಶ್ರೇಯಾ, ಯಾವಾಗ ಪ್ಲಸ್ ತಗೋಬೇಕು ಮೈನಸ್ ತಗೋಬೇಕು ಅಂತ ಗೊತ್ತಿದ್ಯಾ, or you want any note on that? Okay, see here. You can note down these points which will help you to solve the numericals without wasting the time on plus and minus. So take down these points here. First we will write for the concave mirror. That is, if you have a plane mirror, remember, for the plane mirror, the magnification is always 1. For the plane mirror, the magnification is always 1. Okay. This is for plane mirror. Similarly, if I have a concave mirror, for the concave mirror, when you have the real inverted image, the focal length, radius of curvature, object distance, image distance, and object image height, they are negative. So ಇದೆಲ್ಲ negative ಬರುತ್ತೆ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. For the concave mirror, I am telling you. Focal length, radius of curvature, object distance, image distance, and the height of the image, all are negative for real and inverted image. For real and inverted image. Take down this. Next, if you have the virtual and the erect image. So sixth case ಅಲ್ಲಿ concave mirror ಅಲ್ಲಿ ನಾವು virtual ಮತ್ತೆ erect image ಅಂತ study ಮಾಡ್ತೀವಿ. So for that, this is for real and inverted. Next one, second point I am telling you, that is for the virtual and erect image, the magnification will be positive and focal length, radius of curvature, object distance, they are negative, image distance, object height, and the image height ಎಲ್ಲ ಏನ್ ಬರುತ್ತೆ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ. I hope you are understanding. So for concave mirror, ರಿಯಲ್ ಮತ್ತೆ ಇನ್ವರ್ಟೆಡ್ ಇಮೇಜ್ ಗೆ, ವರ್ಚುವಲ್ ಮತ್ತೆ ಇರೆಕ್ಟ್ ಇಮೇಜ್ ಗೆ ವಾಟ್ ಇಸ್ ದ ವ್ಯಾಲ್ಯೂಸ್, ಯಾವಾಗ ಪ್ಲಸ್ ತಗೋಬೇಕು ಮೈನಸ್ ತಗೋಬೇಕು ಅಂತ ಬರ್ದಿದ್ದೀನಿ. ಯು ಕ್ಯಾನ್ ನೋಟ್ ಡೌನ್ ದಟ್. ಸಿಮಿಲರ್ಲಿ ಫಾರ್ ದ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್. ಸೊ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, here only virtual and erect images formed. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಬರೀ ವರ್ಚುವಲ್ ಮತ್ತೆ ಇರೆಕ್ಟ್ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಸೊ ಫಾರ್ that reason, focal length, radius of curvature, v value, h value, h dash value ಎಲ್ಲ ಕೂಡ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. So all values are considered as positive. So this is in case of a mirror. Now I'll write for the lens. You copy down ಮಾಡ್ಕೊಳ್ಳಿ. So for the lenses, ನೀವು lenses study ಮಾಡ್ಬೇಕಾದ್ರೆ, when you have a convex lens for real and inverted image, focal length, h value, v value ಇದೆಲ್ಲ ಪ್ಲಸ್ ಪಾಸಿಟಿವ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. u and h dash ಅಂದ್ರೆ object image height, they are taken as negative. This is for the convex lens. So convex lens is the real and inverted images. You have to consider these all points. One more is there for the convex lens. So convex lens is the virtual and erect image. For virtual and erect image, f, h, h dash ಇದೆಲ್ಲಾನು ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ. Then u and v are negative. Yes, Rehan, copy down this. ಯಾವ್ದು ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಕೇಳ್ಬೋದು. So if it is clear, now you can understand the question, what it is given. You have a concave mirror focal length. So ನೀವು in case note down ಮಾಡಿದ್ದೀರಾ ಅದ್ರ ಮೇಲೆ ನೋಡಬಹುದು. For the concave mirror, focal length is taken as negative, and object distance you need to calculate. So according to the formula, you can substitute the values and you can calculate that. That is 1 by f is equal to 1 by v, mirror it is, so it is 1 by u. So 1 by f is 1 by minus 20, which is equal to 1 divided by minus 50 plus 1 by u. So I can transfer this 1 divided by minus 50 on the other side. So if I transfer that, we will get it as, that is 1 divided by minus 20 plus 1 divided by 50 is equal to 1 divided by this object distance u. This object distance u. Okay. Therefore, the object distance u is equal to, just for answer calculate madidira. So 1 by u you will get, adanna 1 by v only u are convert ಮಾಡ್ಕೊಳ್ಳಿ. So you have 1 divided by minus 20 plus 1 divided by 50 is equal to 1 by u. So here you can see the simplification is there, that is 1 by u is equal to, you will get the answer minus 33.3 centimeter. That is 1 by minus 20 plus 1 by 50 is equal to, you will get u is equal to minus 33.3. Are you getting this answer? See, our ಏನಂತ ಹೇಳಿದ್ದಾರೆ ಇಲ್ಲಿ question ಅಲ್ಲಿ, that is whatever the lens is there, it is placed 50 centimeters from a wall. It is placed 50 centimeters from a wall. Therefore, the total distance between the wall, suppose this is a wall and here the mirror is placed, but you have the image at 50 centimeters from the wall. What is the object distance anta kelidare? So from the mirror namge ಎಷ್ಟು ಬಂತು ಈಗ, we are getting it as 33.3. But from the wall, so from the wall how we can calculate this? That is x is equal to 50 minus u. Therefore it is 50 minus 33.3. So what is 50 minus 33.3? It is nothing but 16.7 centimeters. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ ರೆಹಾನ್, ಶ್ರೇಯಾ? It is 16.7 centimeter. So copy down this. If you are not understanding, you are free to ask. Don't hesitate. Clear your doubts. So if it is clear, you can copy down the next question. And we will end the class. In the next class, we will continue. So see the question. I hope it is all visible. An object is placed at a distance of 40 centimeters from a concave mirror of focal length 15 centimeters. If the object is displaced through a distance of 20 centimeters towards the mirror, by how much distance is the image displaced? So copy down this. We will continue in the next class solving of the exercise. Okay. Just copy down, then we will finish this. Okay. Thank you.